This is October, November 2022, variant 42 question. Number 3A. We have to state the equation of state for an ideal gas can be written as PV equals NKT. State the meaning of each of the symbols in this equation. This question carries 3 marks. This pressure, volume, and Boltzmann constant carries 1 mark. And then the number of molecule is 1 mark. And then the thermodynamic temperature is 1 mark. It means you must say that the P is representing the pressure of the gas, the V represents the volume of the gas, your K represents the Boltzmann constant, and then your N represents number of molecules, and your T represents thermodynamic temperature. For part B, use the equation in A to show that the average translational kinetic energy of a molecule of an ideal gas is given by this formula. This question carries 2 marks. To get the 2 marks, you must first use, beside PV equals NKT, you must use PV equals 1/3 NmC squared, where C squared is the mean square speed, N is the number of molecules, M is the mass of 1 molecule. Then you equate the 2, you get this NKT equals 1/3 NmC squared. You can cancel off the N. Therefore, you get KT equals 1/3 MC squared. Then you multiply both sides by 3/2. This will give you 3/2 KT equals 1/2 small m C squared. But then your 1/2 m C squared is the kinetic energy of 1 oxygen molecule or 1 molecule. Therefore, your EK equals 3/2 KT, which is proven. But see, the mass of an oxygen molecule is 5.31 times 10 minus 26 kg. It means the small m for oxygen is this value. Assume that oxygen behaves as an ideal gas. Use the equation in B to determine the root mean square speed U of an oxygen molecule at 23 degrees Celsius. This question carries 3 marks. The first mark is to convert your temperature from degrees Celsius to Kelvin, which will be 296 Kelvin. Then we use the average translational kinetic energy equals to 3/2 kT. You can get your C squared, the mean square speed of the oxygen molecule. Then you square root the thing, you will get the root mean square speed U of the oxygen molecule, which is 480 meters per second. For part 2, a fixed mass of oxygen gas at initial pressure P is sealed in a cylindrical container by a movable piston at one end, as shown in figure 3.1. This is a diagram for 3.1. The temperature of the gas is 23 degrees Celsius. The piston is slowly moved into the cylinder so that the oxygen gas is compressed. At all times, the oxygen gas and the container remain in thermal equilibrium with the surroundings. On figure 3.2, we have sketched the variation with pressure of the root mean square speed of the oxygen molecules as the pressure increases. To do this question, we need to know that the surrounding has a constant temperature. This is a surrounding, the temperature is constant. The oxygen gas and the container remains in thermal equilibrium with the surrounding. This means that the gas and the surrounding are at a constant temperature. Now, since the temperature of the surrounding is constant, it means the temperature of the oxygen gas is also constant. And that value is 23 degrees Celsius. Therefore, it means when the piston is moved into the cylinder to compress the oxygen gas, the temperature of the oxygen gas remains constant. A constant temperature for the oxygen gas means that the root mean square, the mean square speed U of the oxygen molecule is constant. That means when you draw a graph which is horizontal, which is carrying 1 mark. And then the horizontal line must pass through this point, PU, to show that at the pressure of P, the root mean square speed is U. This is a summary of the facts that you must know to solve this question. You must be able to state the equation of state for an ideal gas. Understand the term mean square speed and root mean square speed. And then you must be able to calculate either one of them. Be able to show that the kinetic energy equals to 3/2 kT, where this is the formula for the kinetic energy for 1 molecule. And then for number 4, you must be able to convert temperature between Kelvin and degrees Celsius.